Today I'll be explaining to you the two main theories of lift. The first one being Bernoulli's principle. For Bernoulli's principle, I want you to think of air like a fluid. It wants to move like a fluid and equalize like a fluid. It wants to move from that high pressure to that low pressure. To visualize this, I'm going to take a piece of paper. I'm going to blow on one side, increasing the velocity of that air, but decreasing the pressure. So I'm going to blow on this side. It's going to be a relative low pressure to this relative high pressure, creating a force going this way. Now, with that in mind, we can move to an airfoil, and as air accelerates over the top of this airfoil, it's going to create a relative low pressure versus this relative high pressure. This high pressure of slower moving air wants to move and equalize up to this low pressure, creating an upwards force. The next theory is Newton's third law of motion, which states that for every action there's an equal and opposite reaction. To visualize this, as a kid, you might have stuck your hand outside the car window and tilted it up. As you tilted it up, the air flowing at your hand would get deflected downwards, which creates an opposite but equal force upwards, pushing your hand up. Now, let's take a closer look inside the wind tunnel.
My wind tunnel setup that I have on loan from NASA. Now in this situation it's impossible to tell, but the air moving over the top of the airfoil is actually moving faster than the air going underneath that airfoil. We'll look at that later in slow-mo. You can tell a little bit that the air at the trailing edge is being pushed down here, and even more so when I put those flaps in, you can tell it's really being pushed down. Why does the air even want to flow so smoothly over the airfoil? This is actually due to the Coanda effect, which is the tendency of the air to be attracted to and flow over a smooth curved surface, which helps the wind connect to and flow over this airfoil shape when it flies through the air. And now for the final example here, we'll show a frame by frame of the smoke going over the airfoil. We can see that it's a little bit faster than the air on the bottom, showing that it's creating that lower pressure on the top of the airfoil. And we can also see on this final frame, I really like this because it's starting to show laminar airflow on both the top and the bottom. And on the trailing edge, it's starting to direct that wind downwards, creating that Newton's force downwards.